We need to transform the polar equation r equals to a squared cosine of 2 theta into its Cartesian equation. Let us begin. So let's say we have a point P with Cartesian coordinate x, y. Then we can represent the x and the y coordinate in terms of r and theta as x equal to r times cosine theta and y will be equals to r times sine theta. Now we can do one thing. We can square x and add it to the square of y. This is going to become equals to r squared. This is one relationship which we'll be using. Now coming to our given polar equation, which is r equals to a squared times cosine 2 theta. So here we have cosine 2 theta on the right hand side. We can use the fact that cosine 2 theta that's equals to cosine squared theta minus sine squared theta. That's a standard trig identity. So let's use that. We get r equals to a squared multiplied to cosine squared theta minus sine squared theta. Now using the fact that x equals r cosine theta, so cosine theta will become equals to x squared over r squared minus, we have sine squared theta, so we can use this equation y equals to r sine theta and replace sine theta with y over r. So squaring it gives us y squared over r squared. Now let's multiply throughout with r squared, so we get r cubed equals to a squared multiplied to x squared minus y squared. Now since we have already defined the value of r squared is given by x squared plus y squared, so r will be equals to square root of x squared plus y squared. We're considering positive values here. So r cubed is going to be equals to, we have x squared plus y squared whole raised to the power of 3 over 2. That will be equals to a squared multiplied to x squared minus y squared. And if you want, we can also simplify it by squaring both sides to get rid of the square root. We get x squared plus y squared whole cube. That will be equals to, so square of a squared will become a raised to the power of 4. So this will be multiplied to x squared minus y squared whole squared. So this is going to be the Cartesian equation or the Cartesian equivalent of our original polar equation r equals to a squared cosine 2 theta.